In a lab colder than deep space, a machine just solved a problem in 5 minutes that would take every supercomputer on Earth 10 septillion years. That's not a typo. 10 septillion years. The universe is 14 billion years old. And right now, the two most powerful nations on Earth are racing to own this technology. Because whoever gets there first doesn't just win computing. They win encryption, medicine, materials, war. This is the race to build a quantum computer that actually matters. To understand the race, you need to understand why quantum computers aren't just faster computers. They're a different kind of machine entirely. A normal bit is a switch, on or off, 1 or 0. Every photo, every message, every video you've ever seen, just billions of switches. A quantum bit, a qubit, is something stranger. Until you measure it, it exists as 1 and 0 at the same time. 2 qubits hold 4 states at once. 3 hold 8. 300 qubits can hold more states than there are atoms in the observable universe. That's the promise. Here's the problem. Qubits are the most fragile objects humanity has ever engineered. A stray vibration, a whisper of heat, a single cosmic ray. Any of it destroys the calculation instantly. Physicists call it decoherence. For 30 years, decoherence made quantum computers a beautiful theory and a practical joke. Then everything changed. December 24. Google unveils a chip called Willow. And Willow does something no machine has ever done. As Google added more qubits, errors didn't multiply. They fell exponentially. This was the holy grail, proof that error correction works. After 3 decades of theory, fault-tolerant quantum computing became physically real. The trick: don't trust any single qubit. Spread the information across hundreds of them, so the machine can catch its own mistakes. One reliable, logical qubit costs hundreds of fragile physical ones, which means the race is no longer about qubit counts. It's about error correction. And that race has 3 American frontrunners and 1 challenger the West keeps underestimating. IBM is betting everything on a 2026 deadline: verified quantum advantage, a useful computation no classical computer can match. Their weapon is a processor called Nighthawk, and a radical error correction architecture that needs 10 times fewer qubits than Google's approach. Google is playing a longer game. Target 2029, a machine called Starling, 200 logical qubits running 100 million operations. And a quieter company, Quantinuum, holds the quality record. Logical qubits with error rates of 2 in 1,000, using trapped ions instead of superconductors. 3 companies, 3 architectures, 1 goal. But this isn't just a corporate race. It's a geopolitical one. China has poured an estimated $15 billion into quantum technology. Its new 5-year plan names quantum a national strategic priority. In late 2025, a Chinese processor called Zuchongzhi 3.2 hit below threshold error correction, the same milestone as Willow, the first machine outside America to do it. The gap between the superpowers isn't years anymore, it's months. Why does a machine that simulates molecules terrify national security agencies? One word: encryption. Nearly everything encrypted today, bank transfers, state secrets, your messages, relies on math problems classical computers can't crack. A large fault-tolerant quantum computer cracks them in hours. Intelligence agencies are already harvesting encrypted data, waiting for the day they can open it. They call it Q-Day, and every government on Earth is now scrambling to deploy quantum-proof encryption before it arrives. But the same power has another face. Molecules are quantum objects. Simulating them is exactly what quantum computers were born to do. New drugs designed in software instead of decade-long trials. Room temperature superconductors, fertilizers without fossil fuels, batteries we can't yet imagine. That's the real prize. Not breaking codes, rewriting chemistry. So where does the race actually stand? Honest answer: no machine today can beat classical computers at anything commercially useful. Yet. But the roadmaps now agree with each other. Verified advantage around 2026. Fault tolerance by 2029. The theory era is over. The engineering era has begun. The transistor was invented in 1947. It took 20 years to change the world. Quantum computing's transistor moment may have already happened. The question isn't if anymore, it's who. And the answer will shape the next century. Subscribe, because this race is just getting started.